Welcome to another edition of a series of lessons on circle theorem. So in this lesson, we will look at theorem 6. We're looking at theorem 6. So this theorem 6, we have a tangent and radius or diameter meet at right angle. A tangent and radius or diameter meet at right angle. So what are we saying? So if you have a circle and a tangent is drawn to the circle, then always radius and the tangent always meet at what? At right angle. Or the diameter and the tangent will meet at what? At right angle or at 90 degrees. That is what we mean. That's what this theorem means. Okay, so if you look here, we have a tangent. This is a tangent, and then we have what? This is the center of the circle indicated O, the center, and then from the center, a line from the center to the circumference. What? It's called radius. So this is what radius R. So we are saying that this theorem says that any tangent and the radius always meet at what? At 90 degrees. So this angle here is 90, and then this angle is also what? 90 degrees. Okay, so when we look at the second illustration, we have a tangent, another tangent, and then you see this is the center of the circle, and we have this chord line going through the center, which is the diameter. That chord is the diameter as I've named it. And then this theorem is saying that always a tangent and diameter meet at what? At right angle. And then a tangent and radius always meet at what? At 90 degrees, which is right angle. Okay, fine. So let us look at this one, figure 2. This figure 2. Here, what can we say? This is a tangent. And this one, line AB. What is line AB? Line AB, here, there's nothing indicating that line AB is a diameter. Have you seen? Because there's nothing is we are not told that AB is diameter. Neither is there any indication of the center of the circle. So we have to be careful of that. In any question, if you are not told that the line is a radius or it's a diameter, you don't have to assume. So that's why we say if you note here, note the diameter of a circle must always be indicated by the question. It is the question that must indicate the diameter, not you as a student. If the question does not indicate the diameter or radius, do not assume any diameter or radius. Okay, don't have to assume anything. Therefore, in figure 2, we can say that angle BAT is equal to 90. Why? You cannot say angle BAT. You cannot say that this angle is equal to 90. Neither can we say that this angle is what? 90 degrees. Why? Since we are not told that AB is a diameter. Have you seen? So we have to be very careful and note this very well. It's very, very important. So thank you. This theorem is very short. Thank you very much, and see you in the next video. Don't forget to subscribe to the channel. Get understanding. How to get understanding. Don't memorize, because if you try to memorize, you will not be able to do very well in exams. Whenever you give you a question and you don't understand, you are trying to memorize, you can get confused. So make sure you understand. So this channel is for you. Anyone who wants to understand or who wants understanding, this channel is for you. If you want understanding and don't want to memorize, then stay on this channel. Whatever is taught on this channel, you understand. You will not memorize. So from henceforth, you no more memorize anything in your life. Thank you. See you in the next video. Okay, students, you are welcome back. So this is a continuation of what theorem 6. We are continuing theorem 6. So there are certain important things you have to note. So note, since the centers are indicated, then clearly OA, line OA is radius, and line what? AB is for diameter. What are we saying here? Look at this side. Here, look here. You see that this one, the center is indicated in this circle. This point is what? Is the center. It's indicated. So since this point is the center, then we know that the distance from the center to the circumference is what? Is radius. So we can confidently say that this one, in any question, if you see something of this sort, then we can say that OA is what? Is the radius. In the same way, looking at this is the center, and the line, the chord going through the center, which is the diameter. I mean, this is the diameter. So if you see something like in the question and you are not told that it's the diameter, then definitely you have to know that the diameter, since what? The center is what is indicated. So that is what you let you note in this in this example. So we are also supposed to note the following very well. So you see that one, a triangle formed by a chord and two radii is isosceles. So always when a triangle is formed by a chord and two radii per second, then that triangle is what? Isosceles triangle. Why? Because look at this. This is the example of what we are talking about. So we have this chord, have you seen? And then we have the center of the circle. This line is the radius and this line is radius. This length is equal to this length because they are all the what? They are radii. So since this triangle, this chord, the radii, these two radii, and then the chord, they are forming this triangle. So in that case, since this length, which is the radius, equal to this length, which is the same radius, it makes this triangle what? AOB isosceles triangle. Fine. That's what the first thing you want to note. The second point is that the perpendicular bisector of any chord of a circle passes through the center of the circle. The perpendicular bisector of any chord of a circle passes through the center of the circle. So this is a chord. So perpendicular bisector, it means that if you divide this chord into two equal parts, then always that bisector will pass through the center of the circle. So that's what we mean. So this bisector, this line, we are bisecting this line. Otherwise, we are dividing this line into two equal parts. So that is why this is where the bisector passes. In that case, the length from here to this point is equal to what? The length from here to this point. That is why we have indicated this line here. And then you know that this one too is what? Is the radius. So this line will also be equal to what? These two lines will be equal, or they are radii. In that case, in the same way, this triangle will also be what? Will be an isosceles triangle. So note that one very well. When you are, always circle theorem, you see this kind of things, in circle theorem. So that's why it's important for us to know. And then we also have this number 3.3 note for isosceles triangle. If you have an isosceles triangle, isosceles triangle has one line of what? Symmetry. Line of symmetry is a line that divides, this thing, whatever, if you see a shape has line of symmetry, it means that line will divide the shape into two equal parts. So this line is a line of symmetry, and then divide the triangle into two equal parts. So this side is the same as this side, have you seen? And since this line divides this one, this side will pass through the midpoint of this line. So this length will be equal to this length, and this length is equal to this length. What you have to know is that line of symmetry also divides the angle at the top to two equal parts. Have you seen? So if you have an isosceles triangle like this, and then you draw a line from the top to meet this side, the base, then this angle will always be equal to this angle. That line will divide the angle here into two equal parts. That is what we mean. That's what we want you to note in this, so that when we are solving questions on circuit theorem, if you see these things in the question, you'll be able to utilize them and to be able to solve the question without any difficulty. Thank you for watching. As I've always been saying, don't forget to subscribe to the channel, get understanding, and then hit the bell notification icon so that additional videos uploaded. When additional videos are uploaded, you will be informed. Thank you. See you in the next video. Okay, students, you're welcome back. So we are looking at an example on Theorem 6. This is an example on Theorem 6. What do you hope you remember Theorem 6? Theorem 6 states that, or says that always the tangent and radius meet at what? At right angle or 90 degrees. And then in the same way, a tangent and diameter, either a diameter or a radius meet at what? At right angle, 90 degrees. So we are asked what in this diagram, you have to find what? You are asked to find, okay, let's look at, we have to find what? Angle. You have to find angle what? Says what? Find the size of angle TOU. Angle TOU, the TOU. So this angle, we have to find this angle. This diagram, okay. So how do you find that angle? That is the question. How do you find that angle? Note that this is not the alternate segment theorem, as we said. Noted this can be the alternate segment theorem. Why? Because the angle between this chord and the tangent, normally this chord should form a triangle on the circumference, but the triangle formed by this chord is at the center. It doesn't form the triangle. This side of the triangle doesn't touch the circumference. In other words, that triangle, the vertices of the triangle formed by the chord, all the vertices do not touch the circumference. So this one is not the alternate segment theorem. So we have to note this is, so this angle in this question we are told that this angle is what, 54 degrees. So don't think that this angle which is 54 is also equal to this angle which we have to find. Don't think that. So that's why we say note that that is not the alternate segment theorem. So this is not the alternate. Why? No, the tangent P is a tangent P meets the chord TU. This chord TU. TU. All the three vertices of the triangle formed by the chord. This is the chord, and the triangle formed by the chord. We have this vertex, and this vertex. Two vertices are touching the circumference. So you see all the three vertices of the triangle formed by the chord do not touch the circumference. Do not touch the circumference. However, since a tangent and radius meet at right angle, angle PTO is equal to 90 degrees. So what we are saying, this is what? This is the radius, and this is the tangent. So it means that the radius and the tangent will meet at right angle. So this angle, angle P, angle TPO, this angle is 90, and angle what? And this angle PTO is also 90 degrees. So from here to here, this whole angle is what? 90, and this angle is what? It's given to 54. So we have to find this angle. Why? You can get this angle. So why do you think that before you can find this angle, you have to get this angle? Yes, because this triangle is what? Triangle TUO is an associated triangle because this is the radius, this is the radius. Have you seen? So that's when we said that a triangle formed by a chord and two radii is always what? Associated. Remember, so that is what is shown here. So you know that associated triangle has two sides equal. So this side and this side are equal. So this is associated triangle. So since this is associated triangle, if you get here, we will to get this very quickly. So how do we get this side? You know that the whole of this is what? 90 degrees, and this is 54. Then if this one is what? This one plus 54 will give us what? 90 degrees. So that's why we are saying that this implies that 54, this 54 degrees angle plus what? Angle UTO. Where is angle UTO? Angle UTO. This side, as I've marked here, is equal to what? 90 degrees, because the whole thing is 90. So this implies angle UTO is equal to what? 90 degrees minus what? Minus 54, which is what? 36 degrees. So this angle is what? 36 degrees. And then, so if this angle is 36 degrees, then this is 36 degrees, because this is an associated triangle. The base angles of an associated triangle are also equal. So we are saying that this implies that what? Angle UTO is equal to what? Angle TU. So this angle here is equal to what? Is equal to this angle, which is what? 36. So if you add this 36 plus this, we have to get what? 180 degrees. The angle, total angles in what? In a triangle. So this implies that 36 plus what? Plus 36 plus TU, the angle we are supposed to find. TOU, this angle will give us what? 180 degrees. So this implies 36 plus 72 plus what? TOU is equal to 180. So TOU is equal to 180 minus 72, which is what? 108 degrees. 108 degrees. So this angle is what? Is equal to 108 degrees. Thank you very much for watching, and don't forget to subscribe to the channel. Don't get understanding. Don't memorize. Thank you. See you in the next video.